Welcome to aminacademy.com. In engineering mechanics regarding center of percussion, let us do some introduction. A center of percussion is the point on an extended massive object attached to a pivot where a perpendicular impact will produce no reactive shock at the pivot. A translational and rotational motion cancel at the pivot when an impulsive blow is struck at the center of percussion. The center of percussion is often discussed in the context of a bat, racket, door, sword, or other extended object held at one end. For example, a batsman hit the ball. He is always getting a shock in his hand. Some point, some particular point at the bat, if the ball hit at that point, the shock will be reduced to the batsman. At particular point, the shock will be zero sometimes. That particular point is called a center of percussion. The same point is called center of oscillation for the object suspended from the pivot as a pendulum, meaning that a simple pendulum with all its mass concentrated at that point will have the same period of oscillation as the compound pendulum. In sports, a center of percussion of a bat or racket is related to the so-called sweet spot, but the latter is also related to vibrational bending of the object. It is found that there is always a point in the body such that if the blow is given at that point, it will not produce any impulse on the body. Such a point is called center of oscillation or center of percussion. Already we have seen. The center of oscillation, C, the point, look here, the point C is here. This is a center of oscillation. May be defined as a point on the line joining the axis of suspension from O and the center of gravity G, through which the resultant of the effective force act as shown in the figure. Consider a force P. Consider a force P is given to the body at point C, that is the center of oscillation. Now consider two equal and opposite forces. Consider forces equal to P to be acting at G also. A little consideration will show that the forces will have the following effects of the body. The force P acting through G, which will produce a linear motion with an acceleration A. Second one, a couple with moment equal to P and P into L, which will tend to produce a motion of rotation in clockwise direction about the point G. Now, further more discussion we'll do. Now, P, the force P acting through G will produce an acceleration A such that we can say P equal the force P equal ma, mass into acceleration. From that, I can say A equal P over m. Similarly, a turning moment PL P into L produce will produce angular acceleration. Will produce angular acceleration alpha which is equal P into L over Ig, moment of inertia through the point G. Now also, now corresponding linear acceleration, let it be A1, which is equal alpha into H, which is alpha equal to already P L, that is H into Ig. Therefore, further you can say that is A1, linear acceleration is PLH over Ig, you can say M kg square, where the radius of gyration, kgs. Now P equal to MA, let it be, this is equation 1. Here this acceleration is, let it be 2. Now if the axis through O, no effect on impulse, no impulse, therefore A should be equal to A1. A equal A1, which gives equating P over M equal PLH over M kg square. P and cut, M also cut. Further we'll get with kg square equal LH. Let it be 3. We know that M kg square equal M mk0 square through O mkg square plus mh square, theorem of parallel axis. From that, both m cut everywhere, then we can get k0 square equal kg square plus h square. Therefore, you can say from that kg square equal k0 square minus h square. Now, let it be 4. Equating 3 and 4, we get k0 square minus h square equal LH. Therefore, k0 square equal LH plus h square. They take out h as a common factor, L plus h, which is equal OG into L plus h is OC. This OG and OC. Further, from that OG equal, we can write OG equal k0 square over OC. It is this obvious. The center of suspension O and oscillation C are interchangeable. The distance between these two centers known as the length of equivalent simple pendulum. Therefore, which is here, we'll introduce L, capital L equal L plus H plus L in the figure, which is equal H plus, instead of L you can write kg square over H. Further, take LCM as H square plus kg square. Now we can write time period of oscillation. Time period of oscillation in terms of length of equivalent simple pendulum L. Therefore, T equal 2 pi root of L by G. 2 pi root of L you can substitute as H squared plus kg square over G, that H, that is we are having L equal H square plus kg square over H, we are substituting here. Next, frequency of motion. Frequency of motion is the reciprocal of 1 by, that is T 1 by T, which is equal 1 by 2 pi root GH over H square plus KH square. We have done. Please subscribe our YouTube channel.